Okay, so I explained that in the beginning of the school year, and this is a non-negotiable. That means I'm not gonna discuss it. I explained it, I'll give you some more background on it, I'll give you some more details on it, but Cornell Notes is required. That's it. That's all there is to it. That's my class, and I'll cry if I want to. All right, yeah.
What if you run out of space
Song
like in
from the 80s.
What if you run out of space from the part that you're supposed to write your notes in? Do
You just go on the next page.
All right.
All right, and the idea is to make sure that you have plenty of space for you to revise. As I said, doing those 6 R's, which again we will go over soon again, we'll go over again soon. Those 6 R's are how you learn. So this word that you guys like to throw out there, study. The reason some of you, not all of you, but some of you aren't doing as well as you'd like is you're not doing those 6 R's. And that's it. In part, you're not doing the homework or the classwork or the projects. I can see that in your grades. It's easily identifiable. And the excuse that I didn't understand what was going on is not an excuse. I'm here Monday, Wednesdays, and Fridays after school. I'm here in the mornings from 7 to 8 usually. Today traffic was bad, but I was here by the time you got in here at 7:30. And I'm available. And if you're not making yourself available to help yourself, that's not I can't chase everyone. So if you're having trouble, you need to see me. You can't get here early. You can't stay late. You can get a pass from me to come to advisory and get help then. You can be assigned a peer tutor. You can watch the YouTube videos. You can ask for other resources. And to be honest, nothing we've done is beyond middle school work. Right? Up to now, we haven't even started biology. We have not started biology. All we've done is do the groundwork that you're going to need to understand some of the concepts that are involved in honors biology. And so if you're feeling like, man, this is too much, my guess is that you're not doing enough. But if it is too much, you need help, I'm here for you. So I don't understand. I don't understand why anyone is struggling. And since the reason I say that is because I don't see anyone here after school for tutoring. No, very few people come to me during advisory for tutoring. So you have not spoken up. Cornell Notes is required in this class. And also, I'll warn you, will be required in several classes in this school. All right. So you did a package on scientific notation, and that's the name of today's notes. And what do we have as a header on every one of our pages in our notebooks? Our name. What else?
The teacher, the class.
That's right.
The assignment, and the date.
And the date, right? And the date is written with the day,
The month, and year.
August, the month, and then the year. And that's according to the English department's standardized header that every class is supposed to require. So make sure that you have that header on every page. Anything you turn in should have the header. And please put your full last name. If you want to put your first initial, that's fine. But put your full last name so that when I'm looking things up, it makes it easier. I have 120 papers to grade in each and every assignment. It gets to be annoying when I have to chase down your name. Does that make sense? So please put your full name, last name. All right, Cornell, scientific notation. Believe it or not, it seems, it's one of those things like Cornell notes. It's one of those things that seem harder than it needs to be. It seems harder than it needs to be. But actually, it simplifies your life. It's the same with Cornell notes. You're just gonna have to trust me on this. And I'll give you more and more evidence as we go through the year. But
You gonna-
some,
or you gonna stand?
so, when we're dealing with scientific notation, what you're dealing with is these things called exponents. I understand that some of you, who here, raise your hand if you've seen and worked with exponents before. All right, so most of you have some understanding of exponents. There are, scientific notation takes advantage of those exponents. Instead of having to write these giant numbers, big or small, we can write this shorthand. So when we write 7.5 times 10 to the fifth, what does that mean? What number is that? Yeah?
It's 750,000.
7.5. So I'm going to move the decimal how many times? 1, 2, 3, 4, 5. And what am I going to put here? Zeros. So the number is 750,000, that's correct. Do you see that? It's pretty straightforward. You could make a mistake if you move the decimal one time too few or what have you. And you can always check by counting. It's like it used to be here 1, 2, 3, 4, 5. So you have 5 numbers. The key to scientific notation is that you have at least one whole number, and only one whole number, no more, no less, to the left of the decimal. And whatever it is after the decimal, all right? But as long as you have one whole number to the left of the decimal, zeros you don't have to put, right? They're just placeholders for the most part. But then to the right of the decimal, however many numbers are significant, and we haven't talked about significant digits yet, but we will. Yes?
Doesn't the number have to be less than 10? The whole number in front of it?
Yeah, less than 10 means one whole number. That's what I mean by one whole number and no more than one. But you're right, it needs to be less than 10, because if you have 10 to the left of the decimal, how many numbers do we have? How many digits in that? You have 2. So you only want one digit, right? One digit to the left, right? Everybody okay with that? One digit to the left, just one. No more than that. So 9 would be the biggest number to the left of the decimal. If you have anything bigger, it can't bigger than 0, smaller than 9 to the left of the decimal. All right, so that's it. That's how you do going from scientific notation to the regular notation, right? And you can see how that could save you time and trouble, but actually it gets more amazing. It actually becomes much more amazing on how easy life is if you're using scientific notation. Yeah.
Okay, so it was the, I'm asking, is it the same when it's, this number say 3.2456?
3.24. What is it? What number?
Number 6.
Number 6 says, I see what you're saying. So let's look at that. That's a good one. 3.2456 times 10 to negative 8. You'll notice that the ones on the right, in the box on the right for number 6, they're all negative. The exponent is negative. So you're moving in the opposite direction. That's correct. So that's going to equal, now we're moving it to the left. So let's do that. Let's start here and move it to the left. How many times? 8 times. 1, 2, 3, 4, 5, 6, 7, 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. But oops, this number here is not a 0. What is it?
Three.
That 3, because see, that's this 3 here. All right? So now the number is 3, but of course you still have the 2, 4, 5, 6, right? So if I wrote it clearly, or more clearly, it would be 1, 2, 3, 4, 5, 6, 7, 3, 2, 4, 5, 6. Are we clear? So it's really just a really small number. This is actually a very, very small number. So when you see -8, you see that -8? That becomes a really, really small number. Now that's going to be important when we do pH. It's going to be very important for you to understand that when we do pH. It explains why pH, the bigger the pH, the smaller the hydrogen ions. The less acidic, the bigger the pH. You'll see why. Yeah.
So when we do other assignments, are you gonna, and we like end up having a number like this, are you gonna you want us to like write it in?
It'll always be scientific notation, yeah. And you'll have to, you're going to be required throughout the whole year to do scientific notation and do significant digits, which we'll talk about later.
Will you ever want us to write it in regular?
Maybe I'll accept it in regular in the future, but really it's, will you have to go backwards? Yeah, sure, you'll have to go both ways, yeah. Yeah, it's not going to be on your end of course exam, they don't test it in this class. But understanding pH, if you understand this, understanding pH is a lot easier for you, yeah.
Can you do number 9?
All right, but let me first double check that everybody has this. So you see where you have the positive number, it goes big, it's a big number. If you see a negative number, it's a small number. Everybody understand that? If you're going from this negative format to a regular number, you're moving the decimal to the left. If you're going from this number to the with a positive 10 to the positive number, you're moving to the right. Now, someone mentioned earlier that there are 2 copies of the answers in your work, and that's correct. There are. The first I wanted you to do, try your best and upload it. The second, I want you to try after we go over the answers, and then you'll upload it again. Does that make sense? So you tried already, leave those mistakes there, write on it as if it were Cornell Notes, circle it and say, I did this wrong, I did that wrong. What are we doing when we do that? We're reflecting. We're reflecting. And when we add additions to those notes, to that work, we are revising. So we're reflecting and we're revising. And then you're going to try it again on the second. You have the answers, right? You have the examples that I walked through. You've tried it on your own. You've watched the little videos, the Khan Academy videos I sent you. You tried it on your own. Maybe you made some mistakes. Maybe you got it perfect, whatever. Now we're going over it. You're revising those notes, any mistakes you're correcting, anything you did well you're noting, and then you're going to do it again. Now if you got it all right, submit the original. You don't have. I'm not going to force you to do it again. If you understand this perfectly, if you feel it's a waste of time, go ahead and upload the original. But if there's any mistakes, you're going to get a bad grade on the second, on today's upload, right? On tonight's upload. Does that make sense? This morning's upload, the upload that I expect by the end of today, that upload, you can be full of mistakes. I don't care. It was you trying. Now I'm going over it, and tomorrow, what do I expect? Perfect. As close to perfect as anybody can get, right? I'd like it right. It should be perfect, yeah. It could be perfect. But if it's one small mistake, it's not going to kill your grade. But I expect most of these to be right the second time. Is that fair? Okay. And if you need help, what can you do? Come and get me. Get a pass. We end today. You need more help. Get a pass from me before you leave. Hand it to your advisory teacher. They take attendance. You come here. You get some help. You can't come after school today. I have a meeting. Tuesdays and Thursdays I'm in meetings. But Wednesday morning, tomorrow afternoon, tomorrow morning, if you need help, tomorrow during advisory. Do you see how this works? There should be no one leaving here. I shouldn't get any calls, any messages from parents, from grandparents, from aunts and uncles and cousins or what have you. Why is my kid not doing well? Why is my kid confused? How do I get her help? How do I get him help? That should not happen, should it? I can guarantee you it will happen. And I guarantee you it'll happen because some of you think that you're just going to sit there and everybody's going to be okay with you not doing well. Guess what? Nobody's okay with you not doing well. Don't eat in this classroom again. I don't know what part of I am watching do you not understand. Okay? Do we get this? All right, yeah.
Instead of putting like the times symbol, can you put 10 to the 6th in like 10 to the power in parentheses?
No. You do it this way. This is the way it has to be done. The reason is that the parentheses, you're writing mathematics, that it would be 10 multiplied times this and you would do it. That's not what it is. In fact, if you're using a calculator and you want to put this number in a calculator, you do not put 10.32456 times 10 to the negative 8. You don't do that. What you would do to write it is you would, now pay attention because a lot of you have calculators. You should have calculators as part of your supply list. You're going to put, if you were trying to write this number type it into the calculator, you would put 3.2456 EE. That's the button on your calculator that you would push, and then negative 8. That's what you would push. Are we clear? Now every calculator is slightly different, so you might have some other button you'd have to push. But in general, most calculators I see it's EE. Okay. All right. Now there was a question about one of these that needed to be answered. What was it? Okay. What was the other one that needed to be answered? No other problems on this page? I can go on. We can move on to the next step. Which one?
Number 9.
Number 9. The positive or the negative?
The positive.
The positive. So another example, and so let's make sure we number these correctly. This is 1, example 1. This is example 2 here. So another example, example 3, and I'm not going to do all of them. I'd like to see you try to do a lot of these again if you messed it up. Number 3, we're going to do problem 9, and it's the positive form, and that's, oh, I don't know what just happened. I see. We're going to do number 3, which is the positive form, and that's 0.1890097. Now the question is, how do you write that in the positive form? And in other words, not really positive form, but how do you make this in a scientific notation? It's not positive or negative, excuse me. There's what?
3 zeros.
Oh, 3 zeros, thank you. My bad. I thought these were divided into positives and negatives. They're not. They're just the ones on the right. So this is actually still a negative form, okay? So how do we write that in scientific notation? Well, what we would do is we'd move the decimal how many times?
1.
1 time. I know that's kind of crazy because you're like, well, look at this big number. But what's our goal? 1 whole digit to the left of the decimal, 1 single digit, bigger than 1, smaller than 9, 9 or smaller, 1 or bigger. So then that would make this 1.890097. Now, without any significant digits, this is fine. If we were doing significant digits, we'd talk more about when can we cut it off. Because a lot of us would like to cut it off here, right? Because you could write 1.89000, or I'm sorry, 1.89001, right? You could write 1.89, right? You could put 1.9. Heck, you could round this off to 2. So where do you round it? How far do you round it? So that you minimize rounding error. What, are there any rules? Well, there are rules, and we call those rules significant digits. And we'll talk more about that later. But that's how you do scientific notation. Now, why is it important? Now, let me show you what some amazing stuff. But before we do, if this were the end of these notes on scientific notation, then I would probably want to summarize them. I'd want to add some stuff to them later. I might add some notes. I might read about something or watch Khan Academy. And I might add a rule, right? Rule 1, the what's left of the decimal rule, right? That might be something I add. That would be revising my notes. And then I would summarize it with 2 ways of writing significant digits.
Would that go in the summary part?
This is the summary, right? That is what we just did. 2 ways of writing significant digits. So I would wait to do my summary at home because maybe I read something in the book, or maybe I watch something in a video that helps me really crystallize the main idea for that day's notes. And I would write the summary for the day, not for each page. Because sometimes the ideas continue. So you want to summarize the idea. It could be after each page, it could be after the day. Maybe we spend a whole day on the idea. And you just write the summary at the end of the day, whatever works for you. Is that clear? But the summary is your summary of what you've learned that day. When I see blanks here, when I grade your notes and I see blanks here, that tells me you learned what? Nothing. And so what grade do you deserve? Nothing. All right. So today, this was scientific notation. And now let's go on and see why is scientific. Now let's go ahead and do some problem sets. But why this is beyond the scope of this page of this homework. Now you guys should be able to do the second half of this and complete, do it again and complete it without any help from me. But why do we do scientific notation at all? Look at this. 0.37614. Now all right, well, let's just leave it like that. Divided by 0.1025. Can anybody do that without a calculator easily?
Maybe.
All right, let me make it simpler just so I don't. All right, so let's say without rounding. I'm not talking about rounding. So 0.24612 divided by 246. You know what? Just 24. Let's just make it easy. Heck, I'll even just do by 2. Divided by 2. Is that something that could easily be done? I mean, you can do it, right? You could draw your little box and put your numbers inside and move your decimals, right? Then watch how easy it is when you're writing it in scientific notation. So write both of these numbers in scientific notation, and it's 2.4612 times 10 to what? Times 10 to? -1. And then I go ahead and I'm dividing by 2, 0.0 times 10 to the first power. Ooh.
How come you put 0.0?
Oh, not times to the first power, I'm sorry. I guess we could just leave it at 2.0. So how do we do it? Well, what can we do? 2.0 times 10 to the 0 power. There. How's that? What is 10 to the 0? Anybody know? 1. Yeah, 10 to the 0 is 1. If I multiply this times 10 to the first power, then that would be no good because I'd have to move. It would be 20, wouldn't it?
Yeah.
Yes, bless you. So I should have been 10 to the 0. That was my bad. All right, so when you're dividing scientific numbers, when you divide numbers that have significant digits, or not, I keep saying significant digits, I'm sorry, scientific notation, you subtract the exponents. You subtract the exponents. So it's going to be -1 minus what? 0. All right? -1 minus 0. So when I divide this number, so then what all I have to really do is then divide what? By 2. I divide this number by 2, right? This number gets divided by 2. Do you agree? So then that number becomes what? 1.236 times what? 10 to the negative 1. And now knowing scientific notation allows me to make this complicated division without having to do all those zeros and manipulating the ones and you know, even rounding, right? Do you agree?
Yeah.
So it really does simplify your numbers. So when you're dividing by the numbers, you subtract the exponents. If I were to do this, 0.24612 times 2. Well, that would be, what would I have to do if I did that? I'd have to do all the decimals, I'd have to multiply, I'd have to count how many decimals, right, and move it over. Do you remember how to multiply decimals? It gets a little crazy sometimes. But what's interesting is if I do 2.4612 times 10 to the negative 1 times 2.0 times 10 to the 0, obviously this is a very simplified form, but when numbers get really complicated, this becomes really handy. Then that's going to equal what? Well, it turns out if I'm multiplying, I add the exponents. If I'm dividing, I subtract the exponents. Is that understood by everybody? Is that okay with everyone? So it's written on the board, but if I'm multiplying, if I'm dividing two exponents, I subtract them, right? As long as the base is the same. See how these are both base 10? If it's a different base number, I can't subtract or add them. But as long as the base number is the same, I can subtract these two. Negative 1 minus 0 is negative 1, so that's why this is still negative 1. Do you see that?
Yep.
So now, these two, I'm going to add the exponents. And then, of course, all I got to do is multiply this times 2. So what's that number times 2? It's 4, 2, 2, 1. That's 8, 9, 4.924 times 10 to the what? Times 10 to the negative 1. Why is it negative 1? Because what's negative 1 plus 0? Negative 1. Did I do that right, by the way? I think I did right in my head. But you see how the number is really easily done, and it would just be, it makes life a lot easier when you're using scientific notation. And those of you that are doing physics or AP Environmental Science or AP Biology, and most of you will do that before you're done here, this scientific notation really makes your life a lot easier when you're solving problems. Yes?
You got the 2 for the 6 and the times plus 2.
Wait, what?
It's
It's another 2.
224. Oh, sorry, I missed. Yeah, that's right. Are we good? All right, so the point is that scientific notation is going to make your life easier. So make sure you practice it, make sure you know it. And when we look at logs, I'm not going to do that today, but when we look at logs, what you're going to see is we take this number and we can solve, the log of a number is the exponent. And we'll talk more about that later. Okay? All right, so it's 8:31. what I'd like us to do is take a break from this for a moment and then come and give me any of your safety contracts. I'm gonna give you your safety test, so you can take your safety test. Remember, you have to do well on it in order to do the lab this week. We have a lab this week. I'd like us to dissect some cow eyes and do some, it's not, I really get nervous when students get all excited about dissecting cow eyes. I'm like, no, I get it, it is cool, it is cool. It is gross, but gross isn't always bad. It's good, and there's a safety, it's a good lab for safety. What we're gonna do is we're gonna see what happens when you drop strong acid on your eye. Bad things happen, you're gonna see what happens. Yeah, we'll see. You'll make that decision. So, what I need you to do though is I need your safety contracts first. You can check those off, and then I have to give you your safety test. And then I'll grade those, and those people that don't pass that safety test will have to retake it before they're able to do a lab. All right.